Hello class 10th. In the last lecture we have discussed about the machine and its function, especially mechanical advantage, velocity ratio and the efficiency. Today we will talk about the levers only and two numericals because you are not asking, not putting any query, not a numerical. So I am doing two questions of my section, and let's start the first topic, lever. So what is lever? Any rod, either it is straight or bent, is called lever. Suppose this is the straight rod or it's a bent rod. Both are called lever, but the condition is this rod must have a point about which it can turn, and that point is called fulcrum. So if any rod is capable to move about any point, and either the rod is straight or bent, whatever it is, then the rod will be called a lever. For example, this scale is also a lever. So as I said, the straight and bent rod is a lever. So this is a lever. This point is a fulcrum. At this point I am putting some effort, means I am putting some force, and at this end I am putting some load. So effort is acting downward direction to pull that load up, and initially the load is acting in downward direction. So the distance from fulcrum, as I said in chapter 1, every distance must be measured from fulcrum. So as this point is fulcrum, so from this fulcrum to this effort is called effort arm, and from this fulcrum to this load is called load arm. So using that same principle as in the chapter 1, that was saying principle of moment. If you say that load into load arm, effort into effort arm, so I'm putting that, see here, load into load arm is equal to effort into effort arm. There it was called principle of moment, but here it is considering as lever, so we will say here principle of lever. Okay, remember this is called principle of lever. That is what? Load into load arm, effort is equal to effort into effort arm. And again, just cross multiply, just move some elements here. See here, the load upon effort is equal to effort arm upon load arm. What is this? This load upon effort is what? Mechanical advantage. So in that case, when the mechanical advantage was having the definition, that ratio of load to the effort, now mechanical advantage is having one more definition, that it is the ratio of effort arm to the load arm. So again, see, the mechanical advantage is equal to load upon effort, and as well as the mechanical advantage is equal to effort arm upon load arm. So using these principles, means principle of lever, the levers are categorized into three parts. But how to speak their name, how to pronounce them, this is very important. People are saying first class, second class, third class. Don't say these type of words. This is not the type of lever. These are getting the categories. That's incorrect pronunciation. The correct pronunciation is lever of first order, lever of second order, lever of third order. And other name that you can say, first order lever, second order lever, third order lever. But if you will say first class, second class or third class lever, means you are not saying the correct name of the lever. Don't say first class lever or second class or third class lever. The correct name is lever of class 1, lever of class 2, lever of class 3, or class 1 lever, class 2 lever, class 3 lever, or lever of first order, lever of second order, or lever of third order. Clearly memorize this. And now starting, so first one, lever of first order, or you can say class 1 lever. See here, in the class 1 lever and class, I'm showing first all the three. See, in the class 1, the first one, the fulcrum is in between the load and effort. This is called class 1 lever. In the second one, the load is in between the fulcrum and the effort, class 2. And in the third, effort is in between the load and fulcrum. This is called class 3. So we are talking about first class 1 lever. In the class 1 lever, the distance from F fulcrum to the load is load arm, from fulcrum to the effort is called effort arm. You can change the effort arm and load arm by moving the fulcrum toward the load or moving the fulcrum toward the effort. So what is the mechanical advantage of this? Means lever. So mechanical advantage is defined as the effort arm upon load arm. Which arm is longer? So you will say it depends upon the position of fulcrum. Exactly. So if the fulcrum is closer to the load side, if the fulcrum is closer to the load side, so effort arm is more than load arm. At this time mechanical advantage will be more than 1. But if that fulcrum is exactly in the middle, if this fulcrum is exactly in the middle, at this time effort arm and load arm both are equal, so mechanical advantage will be 1. And if the fulcrum is closer to the effort arm, so load arm will be longer than the effort arm. At this time mechanical advantage will be less than 1. Remember and keep remember and never forget this point. If mechanical advantage is greater than 1, so machine is force multiplier. Remember this, if MA is greater than 1, so it is machine is force multiplier. Second, if mechanical advantage is equal to 1, so this is used to change the direction of effort. This machine is used to change the direction of effort. And third, if the mechanical advantage is less than 1, then this machine is a speed multiplier. So I said a machine can have 3 functions: force multiplier, speed multiplier and change the direction. So here a single lever, means class 1 lever, can perform all the 3 type of functions. Class 1 lever only can perform all the type of functions. What? As a force multiplier, as a change the direction, or as a speed multiplier. Because the fulcrum can change the position accordingly, the mechanical advantage changes and the function of machine changes. This was about the class 1 lever. So what we have got, class 1 lever has fulcrum in the middle between the load and effort. Second point, it can change its mechanical advantage from less than 1 to more than 1, going through equal to 1. And the cases says some examples. What are the examples? Scissor has fulcrum where? In between. So scissor has mechanical advantage less than 1. Why? In the scissor, see this, in the scissor, from fulcrum to the effort, so from fulcrum to the load, the longer arm. From fulcrum to the effort, shorter arm. So this is a speed multiplier. Second, the claw hammer. In the claw hammer, you can see here, in the claw hammer, the distance from load to the fulcrum is shorter than the distance from fulcrum to the effort. So effort arm is here more. So this acts as a force multiplier. And seesaw, this one. In this case, the effort arm and load arm both are equal. So this is used to only change the direction. So remember, class 1 lever can perform all the 3 type of functions. Less than means as a force multiplier, as a speed multiplier, as a change the direction. It can perform all the type of functions. Let's start the class 2 lever. As I said, class 2 means where the load will be in between the fulcrum and the effort. See the diagram first. In this diagram, the load is in between the fulcrum and the effort. Means whatever you can change, what? The position of load. On changing the position of load from closer to the effort or closer to the fulcrum, the effort arm will be always longer than the load arm. See this. You can change what? The position of load. You can change closer to effort or closer to fulcrum. But in all the cases, the effort arm will be always greater than the load arm. So if effort arm is always greater than load arm, it means the mechanical advantage always greater than 1. So if in examination it is asked that a lever which has always mechanical advantage more than 1, always, if it says always, means it is belonging to class 2 lever. If it is saying just more than 1, means it can belong to class 1 and class 2 both. But in examination it will be written always. Always means it is belonging to class 2 lever. So again, see, the effort arm is more than the load arm. So mechanical advantage more than one means the class 2 lever will act as a force multiplier always. And examples are nutcracker. See this. This nutcracker has effort at this point, load in the middle, and the fulcrum at this point. So in this diagram, what you can see the effort arm from here to here is longer than the load arm. So if effort arm is more than load arm, means mechanical advantage more than one. If mechanical advantage more than one, means it's a force multiplier. Some more examples are here in the book. You must go through. And the case 3, the last one of the lever, means class 3 lever, not class 3rd, class 3 lever or order of 3. See, in this lever, the effort is in between the load and fulcrum. If this case arises, so in this case you can change the position of effort either closer to the load or closer to the fulcrum. Whatever you can do, you can, but you can't change the load arm that is longer than the effort arm always. So in question, if it is written that mechanical advantage which has always longer load arm, so that is belonging to class 3. Or you can say the mechanical advantage, since the load arm is longer than the effort arm always, so its mechanical advantage will be less than 1 always. So if the question says that the mechanical advantage of a machine is always less than 1, which type of lever? So you will say class 3 lever. Same way, if the mechanical advantage is less than 1 always, so what can be type of examples? The examples are fire tongue. In the fire tongue you can see, in the fire tongue, this point acts as a fulcrum, it is not changing. This point is acting as a effort point, and this point is load. So from load to fulcrum, load arm, and from effort to fulcrum, effort arm. Load arm is longer than the effort arm, so its mechanical advantage is less than 1, and this is belonging to speed multiplier. This is belonging to speed multiplier. Again, revising, the class 1 lever can have mechanical advantage more than 1, less than 1, or equal to 1. Means class 1 can be done all the 3 functions as a speed multiplier, force multiplier, and the change the direction. Second, it has always effort arm longer than the load arm, so it is belonging to mechanical advantage more than 1, always more than 1, so class 2 lever. And in class 3, its mechanical advantage always less than 1, so it's a speed multiplier. I think all the numerical sections are so easy, all the practice problems are so easy. So I'm switching to practice problem 2. I thought both the questions are little bit difficult, not too tough, little bit. So let's see both the numerical section. Chapter 3, practice problem 6, question number 1. The question says, a walnut can be broken up by applying a force of 50 kg. By applying a force of 50 kg, it means without any machine, this can be broken up by 50 kg of force. Now, if the walnut is placed in a machine, that is nutcracker, the length of whose handle is 18 cm and nut is placed at 2 cm from pivot. Calculate the minimum force required to crack the nut. Let's draw the diagram for this nutcracker. A general diagram of nutcracker can be drawn like this: fulcrum, the load, and the effort. So from the question we can take, without any machine it was able to crack by the force of 50 kg, means the load is right now is of 50 kgf. Now what is effort? Effort is questioning that calculate the minimum force required to crack, minimum effort required to crack, so effort is question mark. And says that the walnut is placed, see again clearly, whose handle is 18 cm long. So draw 18 cm, you can say from here to here 18 cm means from fulcrum to effort, 18 cm means effort arm. And the nut is placed 2 cm from pivot. From pivot means the fulcrum, the axis of rotation. So from here to here, the 2 cm according to question means load arm. Let's write the initials. So here are the initial effort we have to find. Load 50 kg, effort arm 18 centimeter, load arm 2 centimeter. Let's write the equation by the principle of movement. By the principle of lever, not movement. By the principle of lever, load into load arm is equal to effort into effort arm. Let's fill all the values. Thereafter, on solving, the effort is coming 5.55. It was clear that without any machine it was being opened by 50 kg. And now we are using a nutcracker. We know that nutcracker is belonging to class 2 lever, which is force multiplier. So definitely our effort will little bit less. So that 50 kg have reduced to 5.5, means without any machine the person was able to crack that with 50 kg. Now with the nutcracker he is now able to open this with the same practice problem, same chapter, and question number 2. A key 5 centimeter long and turns the lever of a lock at 10 centimeter. If lock is opened by an effort of 10 Newton, calculate the resistance offered by the levers of the lock. It means the 5 centimeter long the key and the lever inside the lock is at 1 centimeter distance. The effort to open that lock is 10 Newton, and asking for the resistance offered means asking for the load as a load in the lock. So let's draw first the diagram about this, a key. So consider this is that key. Here we will apply an effort. Here we will apply an effort. Here will be the lever to open the lock. So this will be the load. And this point is turning inside the lock. So it is acting as a fulcrum. According to question, the key is 5 centimeter long and the levers are at 1 centimeter distance. Lever of the lock is 1 centimeter, key is 5 centimeter long. So we got load arm. So the remaining is effort arm, effort to the fulcrum, that is 4 centimeter. And it is being opened by an effort of 10 Newton. So the effort 10 Newton, let's write the initials. So effort is equal to 10 Newton, E8 4 centimeter, load arm 1 centimeter, and load we have to find. Let's write in the equation by the principle of lever. So on solving, 40 L into 1 L is got 40 Newton. Because E was in Newton, so the load will also be. We are ending this session now here, only for the topic levers. In the next lecture, we will discuss about machine and all the parts of extra. But I ask you from your side, please do solve numerical and give me information about the problems. But whenever you are putting any question, mention chapter number, practice problem number, and the question number 2. Till then, thank you.